Well, with this, you should be able to recognize the magnesium ion in this. 2 plus charge, it's in 2A. And then you go to do the sulfate part, and you won't find that on the periodic table. It's because sulfate is a polyatomic ion. It's one sulfur and 4 oxygens bonded together covalently, sharing electrons, and then this whole group of atoms has a charge on it of 2 negative. So even though there are covalent bonds within the atoms of this polyatomic ion, you treat the whole thing as if it's a single entity. And if you can get to that point, then you fall back on the rules we've used before. Charge balancing. You have a 2 plus, you have a 2 minus. You need to have the same amount of positive and negative charge for your ionic compound. The net charge needs to be 0. Therefore, the chemical formula is MgSO4. Now, as far as the group of polyatomic ions you have to work with, that's very book dependent and it's very instructor dependent, just because everybody likes to have their own group of polyatomic ions, and everybody seems to have their own rules as to whether you have to memorize any or whether you're given a list. So just work with the rules that your professor sets up for you. You need to get comfortable with that set though, because you need to be able to immediately recognize if you're working with a polyatomic ion. Like with potassium dichromate, even if you don't immediately remember what the dichromate ion is, you need to remember that it is a polyatomic ion, because you won't find it on the periodic table. You'll find the potassium ion on there. There's the dichromate ion, Cr2O7, 2 minus. So we still have the same rules that we worked with for other ionic compounds. Charge balancing, 1 plus, 2 minus. So you need 2 potassium ions. Therefore, there's the chemical formula for it. And you're still putting cation first, anion second. Those rules don't change. And remember, there were cations where you had to remember the charge, not because of the location of the periodic table, but just because they were ones you have to know, and zinc was one of them. Zinc is a 2 plus charge. And then the hydroxide ion has a 1 minus charge. Now here's something different. We haven't done this before. Except for stock numbers, which we put into parentheses, if we set that aside, we haven't used parentheses in writing chemical formula yet. But you have to here, because you need 2 hydroxide ions to balance out the zinc ion. So you have to put parentheses around the OH to indicate that you have 2 OHs. So there's still charge balancing there, but without the parentheses it doesn't make any sense. The ammonium ion, NH4 1 plus, and there's the formula for the carbonate ion. Now this is a little different because now you have a polyatomic cation, and with charge balancing you need 2 of those polyatomic cations. So you have to put the ammonium ion in parentheses. Hopefully you can see that we're still following the same rules, and with the addition of the polyatomic ions, really the only rule change is when do you use parentheses. If you look at the MgSO4 on the upper left, we didn't use parentheses in it. It's not appropriate to put magnesium in parentheses and sulfate in parentheses. You only use parentheses when you have to, like the 2 examples on the right-hand side. Well, that's writing the chemical formula. But let's look at the name. NaHSO4. How do you look at a polyatomic ionic compound and immediately recognize that it's polyatomic ionic? Because you don't have the names. You have to get the names. Before we were doing binary compounds, binary means two. We have sodium, hydrogen, sulfur, oxygen, 4 things. Therefore, that makes this compound one with a polyatomic ion in it. And you still have the same rules as far as cation first, anion second. So you pull the cation out, and you can name that. We've done that before. So the first part of that name is sodium, so it's sodium something. And then the part that's remaining is HSO4 minus. No, it has to be minus because you have charge balancing going on. So if you go look up a list, you'll see that the name of this ion is the hydrogen sulfate ion. So the name of the cation first, the name of the anion second, the name of this compound is sodium hydrogen sulfate. Now this has got a bunch of things in it. You have to practice with the rules list or with your set of polyatomic ions enough so you can immediately go, let me see, the cation is the first part. Well, it has to be this ion, NH4. Well, it's a plus just because that's the charge on the ion. The ammonium ion. Later on, we'll work with what we call Lewis structures, and the ammonium ion is a very common Lewis structure to learn how to write. And then the part that's left over, that's the acetate ion. So cation followed by anion, ammonium acetate. Acetate ion is commonly written not only this way, but it also is written this way. So you have 2 ways to write the acetate ion. The bottom way, the CH3COO minus, that's emphasizing the organic nature of it, because acetate comes from acetic acid, which is a carboxylic acid. My preference, at least at this stage, is for the first one, C2H3O2 1 minus, but you see both ways. It's very common. Well, what's the cation? Al3 plus. You know what that is. That's the aluminum ion. And what's left over? NO3 minus. Oh, and look at the chemical formula. See how there are parentheses around the NO3, and then there's a 3? That's because of charge balancing. The aluminum ion has a 3 plus charge, and the nitrate ion has a minus charge. So you need 3 nitrates to balance out the aluminum ion. And the formula name is aluminum nitrate. Cation followed by anion. So the first part is iron, and the charge on iron is, wait a minute. Remember, iron, it's a transition metal. It's not one that I have my students memorize. And maybe you remember that iron can have a couple of different charges. So you don't know what the charge is on iron immediately. You have to figure it out. And we figure it out the same way we figured it out with binary ionic compounds, by charge balancing. You go to the part that you do know. And we know the sulfate ion, because we know that the charge is 2 minus on the sulfate. So go back to the chemical formula. In that chemical formula, there are 3 sulfates listed, and each sulfate has a 2 minus charge. So we have a total negative charge of 6, which means we have to have a total positive charge of 6. In the chemical formula, there are 2 irons listed. The charge on the iron ion has to be 3 plus in order to get to 6. 6 for the positive charge, 6 for the negative charge. And since that's a transition metal and falls under those rules we laid out before, it's called iron 3 sulfate. I would suggest anytime you're working out either names or formulas that if you're going from the formula to the name, after you've written the name, to check it, write the formula and see if it matches with what you're given, and vice versa.